Hello everyone, welcome back to the sessions of Computational Mathematics. In our previous session, we have understood what is the principle of mathematical induction. In this session, we are going to solve some of the problems on mathematical induction, different varieties of problem. Number one is, here the statement is given, we have to prove that statement is true for all positive integers n. So let's take the statement P of n, the given statement 1 plus 2 plus 3 and so on, n is equal to n into n plus 1 whole divided by 2. So in our first step, that is our basic step, we show that P of 1 is true. So if we take LHS 1 and RHS, if we substitute 1 to n, then 1 into 1 plus 1 divided by 2, 2 by 2 get cancelled, which is equal to 1. Therefore, LHS is equal to RHS. Hence, we prove that P of 1 is true. Next, our inductive step. We have to assume that the statement is true for n is equal to k. So, we have written the statement accordingly. 1, 2, 3 and so on up to k is equal to k into k plus 1 divided by 2. Now, we have to prove that the given statement P of n is true for k plus 1. So, we have to substitute n is equal to k plus 1 and we got the statement in this way, 1 plus 2 plus 3 plus k plus 1, which is equal to, if we simplify this, we will get this form where k plus 1 into k plus 2. That one we can write it as k plus 1 into k plus 1 plus 1 divided by 2. So, our statement is also true for P of k plus 1 whenever P of k is true. Therefore, we have proved that our statement P of n is true for all the positive integers n. Next category of problem is, they have given the statement in such a way that for any positive integer n cube plus 2n is divisible by 3. The solution for this problem is, we have to consider P of n, that is n cube plus 2n is divisible by 3. Now we have to prove this by mathematical induction. In our first step, we have to prove the statement P of n is true for n is equal to 1. So if we take this statement n cube plus 2n, if we substitute n is equal to 1 cube plus 2 into 1, which is our 3. So here 3 is divisible by 3, hence P of 1 is true. Similarly, in our inductive step, we assume that P of k is true. That is, k cube plus 2k is divisible by 3. If we take k cube plus 2k value as 3m, where m is a positive integer. So this is multiple of 3 means, which is also divisible by 3. So we assume that it is true. Now consider the algebraic expression, that is k plus 1 whole cube plus 2 into k plus 1. That is, we have to prove that the statement is true for n is equal to k plus 1. If we expand this equation and simplify this, we will get 3 into m plus k square plus k plus 1, where this whole term is multiplied by 3. Therefore, we can say that it is divisible by 3. Hence, we proved that P of k plus 1 is true whenever P of k is true. From this, we can conclude that the given statement n cube plus 2n is divisible by 3 is true for any positive integer n. So, these are the different types of problems we will get on mathematical induction. Here are some exercises. Try to solve the problems on by using the mathematical induction. So, in this session, we solved some of the problems on mathematical induction. Thank you.